Hi everyone, this video is going to include lesson 3, which is equilateral triangle. We're going to start by just quickly reviewing what your previous lesson was, which was copying a segment. So we're going to first start by just creating a segment. So to do that, you need to take your straight edge. And if we're creating a segment, that needs to have a endpoint on both sides. So we're going to here create our segment, and I'm going to show that there are two endpoints on each side. There we have it. Also, if you're creating a segment, you should get into the habit of using capital letters to name each endpoint. So I just created segment AB. So that was the first step. Step 2 now says to copy that segment using specifically array. So to draw array, just review, you're going to start with a point, going to take your straight edge, and you're going to continue in one direction from that endpoint and put an arrow. So here's my array. We went over in class that rays should be longer than you anticipate because you never know how big whatever you're copying is going to be in terms of that ray. The last thing you want to do is have to go back and extend a line. It's not the worst thing in the world, but if we're going to be starting this, always get in the habit of making your array pretty long. Now, since we're copying segment AB, when you copy a segment or you copy anything, you can't take the original points that you have. So A and B are no longer A and B. It's a copy of A. So to show that you've copied point A, we call it A prime. I'm going to take down here and I'm going to use this endpoint and call it A prime. Okay, so now just to kind of go over yesterday, to copy, you're going to take your compass and we're going to put the needle on one endpoint, A, and stretch it to the width of point B. We show that we've measured AB by just kind of swinging a tiny arc through B, like so. Now to copy this segment length, we're going to take our compass with the same width, go down to our array, and simply swing a tiny arc through our array. If I were you, I would now put a point right here. This shows that we have segment AB. The intersection of the arc and the ray is a point. You actually have to make that point. And I'm going to make it a little bit big. Here we go. And now we label this as B prime because it is the copy of B. Put this down here, and we have B prime. And that is how you copy segment AB that we created. Okay, so let's move on and start to think about today's lesson. Here's that resource yesterday we talked about on the, or I should say last Wednesday, on the Google Meet, that Math Open Ref. This will be a live link, so feel free to click this in the PDF of the notes, and it brings you to all the construction step by step with videos. All right, so here's the situation that you're going to think about. We have Joe and Marty. They're in the park playing catch. A third friend, Tony, comes to join them, and the three boys want to stand so that the distance between any two of them is exactly the same. So if you actually think about having a catch, how would they stand? The distance between any two of them have to be the same. So where do they stand? Where do they form? Kind of pause this, take a second, think about it. But if I were to be kind of down here and I think about this, we have, let's just say like, we start with Joe and Marty. So there's Joe, there's Marty. And here's Tony. I'll just put Tony right here. And I asked myself, okay, so is Tony the same distance away from Joe as he is Marty? Well, in this case, it looks like he probably is. But then you ask, is the distance now between Joe and Marty the same as it was between Marty and Tony and Joe and Tony? And the answer right now is no. So I have to take this dot and I kind of put it over here, and now it looks to see that, okay, the distance from here to here is about the same, here to here is the same, and here to here is the same. So how do they have to stand? What did we just form? And they actually have to stand in not just a triangle, because any triangle won't work. We call this an equilateral triangle. So that's the first thing. Let me just change the color of this. So you can see that we're going to make this blue. Okay, so they're going to stand in an equilateral triangle. So now you're outside and there's these three boys and, how do they figure it out? How do they figure out that they're equal distances? So, I mean, if they're outside, how could they figure it out? I mean, they could probably measure. Some students say they can kind of take their feet and count the number of feet between them. They could take a piece of string. Um, they can take a ruler, any of those things. So if they're outside and they're actually in real life trying to figure this out, they may use whatever tools they have. So for the boys, they may use whatever tools they have, right? But for us in class, we're not going to, be stepping on our paper measuring feet that way. We're not going to be taking a ruler and measuring. What we're going to use is our compass and our straight edge. Okay, and that's really going to be today's lesson. The objective of today is that you're going to be able to create and construct an equilateral triangle using your compass and your straight edge. So the perfect triangle, so to speak, will be the end result of your construction. Um, Before we do that, let's just talk about what it means for a triangle to be equilateral and get down some ideas. So the first thing that we know about an equilateral triangle, if you break apart the term equilateral, equi, this part here, is referring to equal. And lateral, this part here, is referring to length. So it's truly a triangle with equal length. So the sides, um, actually it should be equilateral to sides. So the sides are equal in an equilateral triangle. All three sides are actually equal. So over here it says the length of the segment. So what do we know about the lengths of the segments? There are three equal sides. With that, then we know if we compare the three sides that we have, there's a side over here. I'm going to highlight that side. And if you wanted to identify this side to someone, you would call this side A, B, because the two endpoints A and B are on that side. Then you have this side over here, which is known as side BC. And then you have this side down here, which would be side AC. So we know that those three sides are equal in length. So you can write a statement. You could write that AB equals BC, which equals C. For this case, when you write this statement, you could also, instead of writing AB, you could call that side BA. You could call this side BC as well as CB, and the same as the last side. You can call it AC or CA. The way we actually show that the sides are equal is, yes, we could write a statement, but we could also add something called a tick mark. So it's like a little dash through the side. So side AB, put a tick mark there. Any other side that has a tick mark, one tick mark, through it would then be equal to the side AB. So I could put this here. Now these sides match, so they're equal to each other. And I put a tick mark here. And now these three sides are going to be equal to each other. So these little tick marks show that the sides are equal. Triangles are not only made up of sides, they're also made up of angles. So what are some things that we know about the angles in an equilateral triangle? Well, first and foremost, generally speaking, in any triangle, the interior angles in a triangle come to 180 degrees. That means all the angles on the inside in a triangle, there are three of them, You add the three of them together, and they always sum to 180 degrees. That doesn't matter if the triangle is isosceles, scalene, equilateral, so on and so forth. Specifically, in an equilateral triangle, if we have three equal angles, and the angles all sum to 180, then each angle should measure 60 degrees, because the total sum is 180 divided by 3, because there's three equal angles, and 180 divided by 3 is 60. So we know in an equilateral triangle, all angles are equal, and each angle measures 60 degrees. Okay, I'm actually going to change the color because this little box here, this is specific to only an equilateral triangle. Okay, so we have all triangles sum to 180, their interior angles, but only in the equilateral triangles are the angles equal, and each angle measures 60 degrees. You can show that angles are equal, just like you could show that sides are equal. In this course, we show that angles are equal by putting a little arc in the angle. So if you look over here at angle A, I know angle A, angle B, and angle C are equal. So I can show that by adding a little arc or a little curve at angle A, adding a little curve at angle B, and adding a little curve at angle C. So that shows that angle A, angle B, and angle C are equal. With that, you could also then write the statement. So I'm going to just put a little statement down here. And I know that the measure of angle A, which is 60 degrees, equals the measure of angle B, which is also 60, which equals the measure of angle C, which again is 60. So there's another statement that goes along with angles. And that really kind of sums up the equilateral triangle and its properties. If you notice to the right over here in this notations box, you actually don't have to write out the word triangle in this course. You are allowed to use this symbol that is a triangle, and then if we see this written, it's known as triangle ABC. So it's just a symbol you want to get yourself familiar with. Okay, so now there are two new vocab terms that we need to talk about, and that is non-collinear and collinear. So they obviously both have the term collinear in it, just one is non. So non, obviously talking about not being collinear. So it might be easier to first discuss what does it mean for us to have collinear points. So when we're talking about collinear, we are discussing points, and collinear points, we could break up this term and see how we can figure this out. So points are co and then linear. So the prefix co actually means like together or with, and then linear, line. So collinear points are actually three or more points that lie on the same line. And the reason why you have to have three or more is because any 2 points are always going to be on the same line. But as soon as you toss in a third point, it could or could not be on the same line. So I'll show you what I mean by that. I'm going to use 3 points. 1, 2, 3. So can I draw a line through these 3 points? Let's see. Actually, let's do it this way. So here's a straight line. Make it thinner. I'll put on an angle. So do these 3 points fall on the same line? Well, there's 1 point. Here's 2 points. Here's 3 points. So we can say that these 3 points are collinear, right? So over here, these are collinear points. Right. So let's see what it looked like if I had 3 points that weren't on the same line. So let's kind of copy this down here. Now take a look. As soon as I take this point off the line, no longer are they sharing the same line. There's no way I can drag this line so that all 3 of them go on the line. So these points are now considered non-collinear points because they're not on the same line. But as soon as I just put in 2 points, any 2 points that I have, no matter how I move my points, a line can always go through them. So that's why in the definition of collinear and non-collinear, we focus on having 3 or more points that are on the same line, being collinear. Non-collinear are simply points that are not on the same line, right? But as soon as you have 2 points, they always lie on the same line. So there are our 2 vocab terms. We do this a lot in math where you kind of break apart a term and try to figure out what can you define. So for collinear, we broke it up to co and linear. So co meaning together, linear line. And if you take a look, it's 3 or more points that are on the same line. All right, so let's actually get into now the construction aspect of this lesson. So constructing an equilateral triangle or an equilateral triangle inscribed in a circle. So we're not just making an equilateral triangle. For this specific construction, our triangle must be inscribed in a circle, right? And if you remember, one of the first lessons we talked about actually creating and constructing a circle, and the key point being that in any circle, you always have to start with the center point. So that's why it's so important now, because now we're taking the circles and we're building upon them. And if that center point wasn't identified in my circle, unfortunately, it'd be a little bit difficult to keep precise with my construction. So what does it mean for something to be inscribed? Maybe you're familiar with the term, maybe you're not, but I'm going to give you 2 diagrams to the left, and I'm going to make one of them represent something that's inscribed, and one of them is not. So let's see if I can do this. All right, so I'll just take like this. And then let's see if I can do this. Don't know if this is going to be perfect, but we'll try. Oh, it's pretty good. Okay, so we have, I'll put an A up here, B down here. We have image A and image B. Before we do this construction, which one do you think is representing a triangle that's inscribed in a circle? And the answer is B. So image B shows that the triangle is inscribed in the circle. Image A just shows that the triangle is in the circle. So this does not represent it being inscribed. The main difference between being in a circle and inscribed in a circle is that when an image is inscribed in any figure, it means that the vertices of that image is touching the perimeter of the outer figure. So I just highlighted the 3 vertices of the triangle, and notice they're all touching the circle. Whereas in image A, my vertices are just floating inside the circle. So inscribed means, for our course, a figure is inside another so that the vertices are actually on the perimeter of the outer figure. And that's really important for this class. We're going to be inscribing many figures in a circle. We also may ask you to sketch something that's inscribed, meaning you don't have to use your compass, just simply sketch something. You always want to ensure that the vertices are on the perimeter of the outer figure. Okay, so now that we've done that, we actually are going to get started with inscribing an equilateral triangle inside of the circle. And remember, this is a video, so should I be going a little fast, you could always pause to catch up or rewind to listen again. So first step is you have a circle. We have our center point, our circle is drawn. Next step in this is that we actually have to start at some point on the circle. So I'm going to pick a point right over here, and I'm going to put a point on my circle. Here it is. This is going to be my starting point. Okay, next step is I need to take my compass, and I need to measure the width of the circle or the radius of the circle. So to do that, remember the radius goes from the center of the circle to any point along the outside of the circle. And my point is right here, already labeled for me. I put a point. All right. Now I'm going to take this width, this compass width, and I'm going to move it so that the needle is on the point on the outside of the circle, and I'm going to adjust it so that I bring my pencil pretty close to the perimeter of the circle. And I'm just going to swing a tiny arc. Don't make the arc too big. It'll get real messy very quickly. Then I'm going to take this measure. I'm going to keep it the same. It's equilateral, right? So it's everything, the sides are going to be equal. And I'm going to move it to the next point, which is the intersection of the arc and the circle. And I'm going to repeat. I'm going to swing another arc. Keep it the same. And repeat. So the needle is on my new arc and circle intersection. Swing a tiny arc through the circle. You have to keep in the same direction. So I'm going clockwise, counterclockwise. I have to continue in this direction. I can't all of a sudden go back to this point and swing an arc on the opposite side. That doesn't work. You have to stay in the direction that you first choose. So move, swing an arc, and go here. Swing an arc. And now before you go ahead, I'm not going to swing the final arc. I'm going to leave it so that I have my point. And the reason being is we'll get to this later, but the relationship of pi comes into play here. So it's not exactly 6 arcs. So I have to just leave it, and you'll see why later in our class. And here I have it. So right now, this is all the work to show that I'm creating my equilateral triangle that will be inscribed in this circle. But the triangle is not created yet. I just have the work. I have to finish it. So an equilateral triangle has 3 vertices. I can't just pick any 3 points. It has to be an equilateral triangle. In order for it to be equilateral, I have to be kind of, have a plan. How am I going to get it to be equilateral? What I want to do is pick every other point. So you have to start somewhere. So I'm going to start with the point that I first did in the beginning, this point right here, my starting point. And then I'm going to skip. I'm not going to use this arc. I'm going to use this arc and intersection and put a point. And then I'm going to skip and put a point here. And then I'm going to skip, and it brings me right back to my starting point here. Now, you're going to take your straight edge and you're going to create the triangle. But you don't want to go along the arc. You have to make sure that you're taking your straight edge and you're taking the point of intersection that is on the circle. So I'm going to go from this point to the point of intersection that's on the circle. And go down here to the point of intersection that's on the circle. And go back to here. And there you have it. That's how you have yourself now an equilateral triangle that's inscribed in this circle. Okay? Again, you can go back and re-listen to the steps. But on the next slide, we're going to now take notes of what we just did. Okay, so here it is. The first step is you have to label and create your center point. The labeling is a good habit to get into. If you forget to label, unless it specifies it, we won't take points off. But after you actually create that center point, you have to construct the circle. Now, there might be a time where a circle is given. So if the circle is given, you can omit step 1. Okay. Step 2 is you have to use your compass to measure the radius of the circle. Remember, that's going from the center to the outside of the circle. That's your radius width of the circle. Okay. Step 3, you need to pick a point on the circle, right? So you're going to actually put a point somewhere on the circle. Now, step 4, you're going to put your compass on that point using the radius width, and you're going to swing an arc so that it intersects the circle. Step 5, you're going to keep that radius width. You're going to move your compass to the intersection that you just made, and you're going to swing another arc. Remember, we're going in the same direction. We talked about this before. You want to keep on moving that compass going along the same direction. You have to repeat this until you have 5 arcs and then that original point. Now, to actually get the triangle, you connect every other arc or point with your straight edge. Remember, it must be on the circle. I'm going to type that down here. want to connect on the circle. It needs to be on the outside of the circle, right? It shouldn't be floating on the inside. And that gets yourself a nice equilateral triangle. Okay, so if you want to practice, I would say kind of pause this, go through the steps again, maybe practice yourself constructing another equilateral triangle that's inscribed in a circle. But in terms of our lesson, we're going to move forward. We don't only construct triangles that are equilateral inside of a circle. Often a segment length is given for us, and we have to construct an equilateral triangle using a given length. So in order to do that, it actually isn't too bad. It's quite easy. And if you think about it, a triangle, an equilateral triangle, is made up of 3 segments that are the same length. So really, you're using your compass, and you're not changing the width of the compass at all. So to do this, we're going to use the endpoints J and R. Open it up. And this is the length of every side. So right now, I have to figure out where's my third point going to be, kind of like when we talked about Joe, Marty, and Tony playing baseball. Where would my third point be so that this would now create an equilateral triangle? To figure that out, I'm going to measure the length of JR. So I'm going to swing my arc to show that I've measured. And my third point, I think, might be up here somewhere. So I'm going to take my compass, and I'm going to swing an arc that's pretty decently big somewhere up here. So I think my third point could be anywhere along this arc to create my equilateral triangle, but I don't know where. I need an intersection in order to create a point. So I have to get another arc. So how do you think we can get another arc? Well, we're actually just going to flip our compass around and now put the needle on R and swing my arc up here. And this arc can be a little bit smaller because I know it has to just intersect my original. So where those arcs intersect is going to be my new point. And for our purposes, I'm just going to call that point, I guess, maybe point Q. Now, I don't have an equilateral triangle. I just have the work to show it's going to be an equilateral triangle. To actually construct an equilateral triangle, I'm going to connect from J to Q and Q to R. And there it is. Now, in some cases, it may say that it wants you to construct the equilateral triangle, but it doesn't want you to use the segment length actually on JR. So if that's the case, if you have to construct the equilateral triangle off the segment, do that down here. So here's my segment, and I need to now construct the equilateral triangle, so this image down here. So in order to do that, we're going to follow similar steps to copying a segment. So the first step is going to be that we have to start with a point. So here it is. Now remember, we're copying J, so I can't call it J. I have to call it J prime. And to copy a segment, I could either use a ray or a point. So I'm just going to use a point. I'm going to go up here, make sure I measure from endpoint to endpoint my original segment, show that I measure by swinging a little arc. Bring this down now to my new point, J prime, swing a tiny arc. And I actually have to put a point on this arc. And I'm going to name that point R prime. Now I have one side of my triangle. But to really show that it's a side, I need to take my straight edge and connect from point to point. And now I just need to get my third point. So I'm going to follow the steps above because essentially now I'm where I was before. So take my take my compass, put needle on J prime, pencil on R prime, swing the arc up, make it pretty big because I don't know where it's going to be along that arc. To find my intersection, I'm going to flip this around, needle on R prime, and go up through this arc. And now I can label my point whatever I'd like. And I'm going to pick something different than Q. I'm just going to put the letter T. I don't have to say T prime because the point T isn't anywhere else on my page. But it's not a triangle until I actually connect T to both R prime and J prime. And there we have it. And that is how you create yourself an equilateral triangle given a segment length, both using the segment length as a side and copying the segment length and then creating your triangle. Okay, so that actually concludes lesson 3, which is creating or constructing an equilateral triangle, both inscribed in a circle as well as using a segment. Remember, at the end of watching this and filling in your notes, you do have some practice questions to complete on the Google Classroom or in Google Classroom. We're going to ask that you do your best to complete those questions using a separate sheet of paper, taking a picture, and uploading it to Google Classroom. If you have any questions, please email us.